So hello everyone, very good evening. Am I audible, my dear students? Am I audible? So today we are going to complete about we are going to solve all the questions related to the topic radiation. And in this topic we will be covering all the numericals. जितने भी अभी तक के numericals गेट में आए हुए हैं, सारे numericals हम practice करेंगे and सारे concepts को भी हम डिस्कस करेंगे जितने भी concepts आपने पहले रिवाइज किए हुए हैं या नहीं किए हुए हैं. And if you have any kind of doubt in your classes, you can ask me here in the chat box. You can just mail me, or you can just send me a message in the chat box. Okay. So let us start. So if we will talk about the radiation, so radiation is the from gate point of view. If we will talk the radiation in the chapter radiation, they are asking the simple questions. Okay, and only you have to revise little bit of concepts and little bit of your formulas. Then you can easily attempt the any question which is provided in the gate question paper. So my dear students, if you are looking for simple questions and you are looking for the complete solution of the gate questions of radiation, chapter radiation on the YouTube, then this video is very useful. And watch this video till the end, and also subscribe this channel and share to your friends so that everyone can be benefited from this. So my dear students, let us start the class. So if we will talk about the radiation, I'm not going to discuss any theory topic here because the videos are already available on the Ekeeda app, and also the all videos and full content of radiation is available on the YouTube itself. So you can go there on the Ekeeda GATE ESC portal and you can directly see the videos related to. If you are having any doubt, there are particular videos available on the particular topic. So you can go and you can easily understand each and every topic in a simple language. Okay. So today only we are going to do all the gate questions. So let us start the class. So I'm waiting how many students are there. You can message me in the comment box if somebody is there. So let us start. So if I will say, let us see the simplest question they have asked in the gate. So if you will see all the questions, I have just prepared this PPT such like that so that every student will understand from basic to the advanced level. So I have just enrolled the basic questions first, then I am just increasing the level little bit higher. So let us see. Let us see, my dear students. So this is your first question. If you will see, so this question they have asked for 2 marks in the gate, and this is the very simple question. If you will see, so anybody in the class, if there somebody want to answer this question, so here I am reading the question. समझने की कोशिश करें, बहुत ही आसान है, बहुत ही आसान क्वेश्चन ये लोग पूछ रहे हैं. बस आपको क्या एक फॉर्मूला आपको याद होना चाहिए. दूसरा आपको जो सबसे इंपॉर्टेंट चीज है वो है गेट में कंसेप्ट और फंडामेंटल्स. में हमेशा कहता हूँ ये चीज वो आपको पता होना चाहिए. तो एवरीथिंग विल बी क्रिस्टल क्लियर टू यू. So now let us see this question. The peak wavelength of radiation emitted by a black body. The peak wavelength, he is talking about the peak wavelength, my dear students. Peak wavelength of radiation, okay, emitted by a black body at a temperature of 200 Kelvin. Okay, there is some temperature of that particular body. Okay, and the radiation emitted by that body is having the peak wavelength of how much? 1.45 micrometer. So my dear students, if you will see, let us see. If you will see this part, so what you will have, let us see. If you will see the solution, so he have given some particular temperature T1. Let us take the body temperature of that body to be T1, which is given to be 200 or 2000 Kelvin. Okay. Now, what is the particular peak of wavelength? Peak wavelength, so lambda 1, I can take lambda P1, I can take to be how much? This can be taken to be like 1.45 micrometer. Okay. Now the second part, if you will see, what he is asking, if the peak wavelength of emitted radiation changes to 2.9 micrometer, if the peak wavelength of the radiation, now he is changing the wavelength. So if he is changing the wavelength, how much he have given the wavelength of peak to is equal to nothing but 2.9 micrometer. Okay. Now, then temperature in Kelvin of the black body is. So already he is giving the black body. So what he is asking about the temperature at the wavelength peak 2. So can we do this question easily? Yes, we can do this question by using your Wien's displacement law. So we know that what we know. We know the Wien's displacement law, my dear students. Wien's, we know Wien's displacement law. So if you will see the Wien's displacement law, what he have given, that peak wavelength, or we can say the wavelength at which the maximum radiation is occurring, you can take wavelength at which the maximum radiation is occurring. That is the like smallest wavelength we have, the peak wavelength, but at which the maximum radiation is occurring, multiply by that particular temperature T is equal to some constant. Okay, is equal to some constant. So you can take. So now, if you will directly see this, I can directly have in this question that lambda P1 into T1 is equal to lambda P2 into T2. Directly, I can have this, and I have to calculate the T2. Can I have the value of T2 now? Yes, simply I can easily calculate the value of T2, which I can easily calculate. Let us see. So this will become, let us put all the values. What is lambda P1? And I'm not changing the units because micrometer is already given and micrometer is already given. So I will got the temperature in Kelvin only. So let us see. So lambda P1 is how much? 1.45 micrometer multiplied by 2000 T1 is given is equal to lambda P2. What is the value of lambda P2, my dear students? Lambda P2. So lambda P2 is equal to nothing but 2.9 multiplied by T2 we have to calculate. So this is the simple question they have asked. So this will become T2, the temperature T2. T2 का मान कितना आएगा देख लीजिए, कैलकुलेट करके आप इजीली बताइए मुझे कमेंट बॉक्स में जल्दी से कैलकुलेट करके. What will be the value of T2? So what will be the value of T2? So the value of T2 will be equal to nothing but how much? Tell me in the comment chat box. Tell me in the chat box, please. So the value of T2 will come equal to 1000 Kelvin, right? 1000 Kelvin. So let us see. Now, if you will see, T2 we are getting already 1000 Kelvin. And I hope you have gone through the Wien's displacement law, the theoretical portion. So this equation gives you the Wien's displacement law. Okay. Now let us move on to the second question. If you will see the second question, so what he has given, that this is a particular question. They have asked this question in the 2017 set 2. Yes, Karthik. Okay. Now, two black surfaces AB and BC of length 5 meter. Two black surfaces AB and BC, my dear students. AB and BC. So two black surfaces. So already he have given the black surfaces. So let us see the solution. Let us see the solution of this question. You know, simple questions they are asking. Simple questions they are asking. So AB and BC, two black surfaces. First of all, he have given the black surfaces. Black surfaces. So what will be the value of black alpha for the black surfaces? So value of the alpha for black surfaces will be equal to how much? It will be equal to nothing but alpha is equal to 1. Okay, alpha is equal to 1. So that will become, let us see. So alpha 1, alpha AB will be equal to how much? 1. Although you should know alpha AB is equal to 1. Similarly, alpha BC for the surface BC will be equal to 1. Okay, no issue. Now, what is the length for this particular given? So length of AB is given to be how much? Sorry. So length of AB is given to be how much? 5 meter. 5 meter, my dear student. Length of BC is given to be how much? Length of BC, how much they have given? Length of BC they have given to be like 6 meter. Okay. 6 meter. Very good. Respectively. Are oriented as shown. Are oriented as shown. Both surfaces extend infinitely into the third dimension. So both the surfaces are extending, like they are extending into the third dimension. Third dimension they are coming, third dimension. Given that the view factor f12, So he have given what? If this is the surface 1, if this is the surface 1, so what will happen? Some part of radiation will go from here and it will fall on the 2. So what is your shape factor? When shape factor, or we can simply say the configuration factor. So this is nothing but the fraction of radiation which is leaving surface 1, which is leaving surface 1 and reaching the surface 2 is called your shape factor. Okay, simply what we have given is, then we have given F12 is equal to 0.5, 0.5. So the fraction of radiation which is leaving surface 1 and reaching surface 2 is given to be 0.5. And temperature T1 they have given to be how much? 800 Kelvin. Temperature T2 they have given to be like 600 Kelvin. And surrounding temperature he have given to be like how much? 300 Kelvin. And also he have given the Stephen Boltzmann constant. Very simple question, my dear friends. Very simple question. Now he is asking the heat transfer rate from surface to the surrounding, or you can say the heat transfer between surface and surrounding. Surface and surrounding. Heat transfer between surface and surrounding environment is in kilowatt. He is asking. In kilowatt he is asking. So what you will have? So let us do this question. So let us assume that there is a surrounding, or we can say that there is a surface 3, which is nothing but your surrounding. So this is your surrounding. Let us say this is your surrounding. Okay. Now simply I will make you clear that how you can easily solve the gate questions and how you can approach the gate questions. So first of all, understand this. What he is asking? He is asking about the heat transfer from the radiation, like by the mode of radiation in between the surface 2 and surrounding environment So how you can calculate? So you have to calculate the heat transfer between surface 2 and 3. For that, what you have to take. So first of all, you must know the configuration factor, which is 2 and 3. So you must know the configuration factor, which is nothing but equal to F23 multiply by area A2 multiply by sigma, and the temperature to the power 4 to the directly you can take T to the power 4 minus T infinite to the power 4. So you have to T infinite to the power 4. Okay. So you have to calculate this value. So do you know the value of F23? So if you only he have given what? F12. So F12 he have given. If he have given F12, can you calculate the value of F23? How you will calculate the value of 23? So if I will see, so according to summation rule, I'm just taking here so that you will know spaces here. According to summation rule, my dear students, summation rule. What we have according to summation rule? So if any body is there, let us say if any body is there and it is exchanging with like one body is also there, one is there, third one is there, like let us say n bodies are there. So that particular body will exchange radiation with all the bodies. Let us say if this is the body 1, this is 2, this is 3, this is 4, this is 5. So similarly n तक आप लेके जा सकते हैं इसको डायरेक्टली, ठीक है. तो यहाँ पे 4 और ये हो गया 5 आपका. तो समेशन रूल कहता है कि F1 से जो रेडिएशन निकला जो 2 पे गया, फिर F1 से जो रेडिएशन निकला उसका फ्रैक्शन जो 3 पे गया, फिर F1 से जो रेडिएशन निकला जो आपका फिर 4 पे गया, सिमिलरली F1 से जो रेडिएशन निकला जो आपका n पे गया विल बी इक्वल टू 1. बट यहाँ पे क्या है, ये क्या है बेटा, समेशन रूल है आपका. ये क्या है बेटा, समेशन रूल है आपका. सो इफ यू विल सी दिस, सो समेशन रूल को यदि हम देखें तो उसमें क्या हो रहा है कि यदि जो 2 से सरफेस से निकला, अभी मैं सिंपली बेसिक से लेके चल रहा हूँ बेटा, बेसिक से एकदम हम जा रहे हैं. सो अकॉर्डिंग टू द समेशन रूल व्हाट विल हैपन, सो आई कैन इजीली टेक दैट F22, the fraction of radiation which is leaving surface 1, surface 2 and reaching surface 2 which is not there will be equal to 0, because यहाँ पे कोई ऐसा रेडिएशन नहीं है जो इस पे आए, because this is a flat surface. और फ्लैट सरफेस के लिए यदि आप सेल्फ व्यू फैक्टर देखेंगे तो क्या हो जाएगा बेटा, वो 0 होगा. ठीक है. तो F22 प्लस F21 प्लस F23 is equal to 1. But F22 will be equal to 0. F22 will be equal to 0. And what will be the value of F21? F21 will be equal to how much? F21 he have not given, but F12 is already given. But you have to calculate F23. So what you can do now? What you can do now? Now you can easily calculate the value of F21. F21 you can calculate because F12 is given, and you can calculate this value by the rule of what? Summation rule. Okay, sorry, reciprocating theorem. तो रेसिप्रोकल थ्योरम कौन सा है आपका, वो देख लेते हैं. तो रेसिप्रोकेटिंग थ्योरम, थ्योरम क्या कहता है वो आप जानते हैं. मैं इसको एक्सप्लेन नहीं करूंगा, आप जाके डायरेक्टली वीडियो में देख सकते हैं. यू कैन डायरेक्टली गो इन द Ekeeda channel where you see, and you can also see there about the complete video of the shape factor. So this is your summation rule. This is your reciprocity theorem that A1 F12 is equal to A2 F21. A2 F21. So if you will see A1, what is the area A1? You can easily calculate A1. Yes. A1, what is the surface 1? This is nothing but BC. BC is the surface 1. So this is nothing but surface 1. So 1 multiplied by LBC. And if you will see the surface 2, A2, this is 1 multiplied by LAB. So A1 F12 is equal to A2 F21. So what is the value of A1, my dear students? So what is the surface value A1? A1 is nothing but BC. So what is the value of BC? This is equal to nothing but 6 meter. BC, this is nothing but equal to 6 meter. Okay. So A1 is BC. So you can take it directly 6 multiplied by F12. What is the value of F12? This is 0.5. Okay. This is 0.5 is equal to A2. What is the value of A2? That is LAB. LAB is nothing but a surface 2. LAB is nothing but a surface 2. So this will become 5 meter multiplied by. Because directly, if you will extend this surface AB and BC, what is the value? So unit width I am taking. Unit width I am taking for the particular length. So this will become nothing but 5 into F21. F21. So my dear students, can you calculate the value of F21 and tell me? जल्दी जल्दी सारे बच्चे निकालेंगे, बताएंगे मुझे F21 का वैल्यू कितना आ रहा है. What is the value of F21, my dear students? Let us calculate. Good evening, beta. Aritra Ghosh, very good evening. So you can directly calculate the value, beta. यहाँ से डायरेक्टली वैल्यू का कैलकुलेट करके आप बता सकते हैं. व्हाट इज द वैल्यू ऑफ F21? यहाँ से F21 का वैल्यू निकालेंगे तो कितना आएगा? 5 विल गो एंड दिस टर्म विल बी इक्वल टू नथिंग बट F21 will be equal to nothing but 0.6. 0.6. So now we know the self view factor. Sorry, now we know the shape factor for the particular, for that particular. Let us see how. So now what is happening is that the fraction of radiation which is leaving surface 2 and reaching surface 1. मान लीजिए यहाँ से 100 आपका रेडिएशन की किरणें निकली. ओके, 100 वेव्स यहाँ से चली हैं. एंड लेट अस से 20 यहाँ पे कितनी पहुंच रही है? 60% ओनली पहुंच रही है. 100 में से 60 यहाँ पे पहुंची है. 100 में से 60 यहाँ पे पहुंची. यहाँ से 100 निकली इस वाले सरफेस से. सिंपली आई एम टेलिंग यू बिकॉज बहुत सिंपल है, ज्यादा दिमाग नहीं लगाना है, बहुत सिंपल कंसेप्ट है. सो इफ यू विल सी दैट 100 rays are coming out from this particular surface 2 and only 60 rays are reaching there. So what will be the self-view factor? The fraction of radiation reached at surface 1. So that leaving surface 2 and reaching surface 1. So this is nothing but 0.6, which can you, if you will take my example, this is nothing but 60 upon 100, my dear students. 60 upon 100 directly it will come what? How much? 0.6. Okay. Now we have found that that much of radiation to leaving surface 2 and reaching 1. So now can I calculate that how much of the radiation is leaving surface 2 and reaching surface 3? Yes, I can calculate from the summation rule. Summation rule, my dear students. So now this self-view factor is become 0 because this is the flat surface. So F21 कितना है बेटा? जरा बताएं मुझे. How much is the value of F21? So F21 is 0.6. Okay, very good. So F21 is 0.6. I am going slowly so that each and every student can understand properly. So what is the value of F21 now? So let us calculate the value of F23, which is equal to 1. So the value of F23 will be equal to, the value of F23 will be equal to 1 minus 0.6, which is equal to 0.4, my dear students. Okay, I hope this is clear. So we have calculated the value of F23. So now we know F23, we know A2. What is the value of A2? Which is nothing but the surface AB, surface 2, having the 5 meter length and one width I have taken in the third dimension. So this will become equal to nothing but F23 multiplied by, that is nothing but 0.4 multiply by A2, which is nothing but 5, multiply by sigma. The value of sigma is how much? 5.67 into 10 to the power minus 8, 10 to the power minus 8, and the value of surface T2. What is the temperature T2? T2 is 600 Kelvin, my dear students. So you can directly take 600 Kelvin to the power 4 minus what is the value of surrounding temperature? That is nothing but 300 Kelvin to the power 4, and directly you can have the value of 2, 2, 3 here. The heat exchanger between the surface 2 and the surrounding you can easily calculate. So tell me the answer first. So fast, tell me the answer. My dear students, tell me the answer, please. How much will be the value? Into 10 to the power minus 8. Okay, very good. So that particular value is coming to be how much? 13,778.1 watt per meter, my dear students. Watt per meter. So this will be the particular value. This will be the particular value. And I hope you have got this question. So directly you can, Aritra Ghosh, are you there? You can ask me any doubt, if any doubt is there in this question. So we have only used the simple concepts of that particular radiation topic. And this is the 2 mark question. And if you will डायरेक्टली डू दिस क्वेश्चन, यदि आप डायरेक्टली करेंगे तो सिंपली आप सारी चीजें अवॉइड करके इसको बहुत जल्दी खत्म कर सकते हैं बेटा. दैट विल ओनली टेक 2 मिनट्स टू सॉल्व. ओके, 2 मिनट्स में या 1 मिनट में आपका ये क्वेश्चन हो सकता है डायरेक्टली. सो इफ यू विल सी द थर्ड क्वेश्चन नाउ, लेट अस सी. So this is the third question, and this is a simple one. We have done this kind of question, so that's why I have just given the answer also. So the spectral distribution of radiation from a black body at temperature T1 is equal to 3000 Kelvin, has a maximum at wavelength lambda max. Okay, has a maximum at wavelength how much? Lambda max. The body cools down to a temperature T2. Now lambda max is nothing but, I have already told you that lambda max, this is not the maximum wavelength, this is the shortest wavelength at which, this is nothing but the shortest wavelength at which maximum radiation is occurring. Okay, maximum radiation is occurring, जहां पे मैक्सिमम रेडिएशन हो रहा होगा बेटा, स्मॉलेस्ट लेंथ पे. ठीक है. सो नाउ वी हैव गिवन द T2. He is asking the T2. The body cools down to a temperature of T2 if the wavelength corresponding to the maximum of the spectral distribution at T2 is 1.2 times the original wavelength lambda max. Then the temperature T2 is in Kelvin, round off to the nearest integer. That they have asked in the set 2, simplest question, set 2. क्या है इस क्वेश्चन में? What they have asked? Does this question deserve the 2 marks? Does this question deserve 2 marks? No. So this is the 2 mark question they are asking in GATE. This is the simplest question they have asked. So what? You have to directly use the wind displacement law. So if you will directly do what here is that lambda 1 T1 is equal to lambda 2 T2. Simple. We have done this kind of question. So directly he have given T1, lambda 1 he has given, and lambda 2 he has given. What is lambda 2? Lambda 2 is nothing but equal to 1.2 times of lambda 1. He have given this. So if you will directly put the value that T1 lambda 1 or lambda 1 T1 is equal to lambda 2 T2, and you can directly put the value of lambda 2, which is 1.2 lambda 1 into T2. So directly lambda 1 and lambda 1 will go. So you will have the value of T2, which is equal to nothing but how much? T1 into T1 divided by, that is T1 is given to be 3000 divided by 1.2. So what will be this value? T1 divided by 1.2. This will be 2500 Kelvin. So this value will become equal to 2500 Kelvin. And I hope this concept is also clear. So they have asked only the simple questions. What is there in this question? Simple question, formula based, only of 2 marks. Only of 2 marks, my dear students. Only of 2 marks. Okay. Now let us see the second one. So this is the question. Now, so this is the question from the set 1 GATE 2016, and that is of 2 marks. Okay, this is of 2 marks, my dear students. कितने नंबर में पूछा गया बेटा? 2 मार्क्स में. ठीक है, सिंपल क्वेश्चन है ये भी, तो कोशिश करें आप करने की, यदि आप कर रहे हैं तो. यस, रित्रा घोष, अंजनी, प्रणीत, हेलो हेलो बेटा. अंजनी, Pranit, yes, ask, you can ask me any doubt here. You can ask me any doubt. So ask your doubt, please. Ask your doubt in the comment box. Anjani, you can ask your doubt here, beta. So let us see this question. So all students, please focus on the questions. Let us see. So what he has asking, let us see. So they have given an infinitely long furnace of 0.5 and 0.4 multiplied by 0.4 cross section. So cross section they have given. So let us see, this is the furnace. This is the furnace, my dear students. Okay, and in furnace, you know, there are high temperatures. Okay, and they have also given the some area. Area they have given, the cross section they have given. So what is the cross section? That is 0.4 meter. This is 0.5 meter. Okay, so they have given length and width to be like height and length and width you can take. Length and width to be how much? 0.4 and 0.5 and 0.4. It's shown in the figure out. Consider all surfaces of the furnace to be black. So okay, so I have to take the absorptivity and emissivity is equal to 1. Okay, now the top and bottom walls are maintained at temperature T1. Now what he have given, the top and bottom walls at maintained at temperature T1, T3 is equal to 927 degrees Celsius. So top and bottom are equal to the T3 and T1 are maintained at that same temperature. So can I take directly here that T1 is equal to T3 is equal to nothing but 927 degrees Celsius, or I can also take this to be like 927 plus 273, my dear students. How much? 273 plus 27, 1000 plus 200. This will become 1200 Kelvin. Okay, 1200 Kelvin. Now let us see the next. While the side walls are at a temperature of T2 is equal to T4 is equal to 527 degrees Celsius. So T2 and T4 value they have given. So what is the value of T2 and T4? I'm directly doing the question. I'm not writing any much, so you can easily understand. So 527 degrees Celsius. So 73 plus 500, 600 plus 200. This will become 800. Okay. 600 plus 200 will become 800. So directly you can do like this, 527 degrees Celsius plus 273. So why you are converting in the Kelvin? Because in the Stephen Boltzmann equation only we use the all values of temperature in the Kelvin. Okay, so this is the concept you can easily do. Now 800 Kelvin this will become. Now the view factor F12 is 0.26. So he have given the fraction of radiation leaving surface 1 and reaching surface 2. So he have given the value of fraction of radiation leaving surface 1 and reaching surface 2. So F12 he has given. So what is the value of F12, my dear students? F12 he has given to be 0.26. Very good. The net radiation heat loss or gain on side 1 is Stephen Boltzmann constant he have given. So my dear students, he is asking the net radiation heat exchange between one and all surfaces. Okay, so बहुत ही प्यारा क्वेश्चन है, लेकिन बहुत से बच्चे क्या करते हैं शुरू में थोड़ा सा उनको डाउट होता है, तो बस थोड़ा सा बेटा आपको थोड़ा सा ध्यान से क्वेश्चन को करना है और डायरेक्टली यू कैन हैव द राइट आंसर. ओके, डायरेक्टली यू विल हैव द राइट आंसर. सो यस, यू कैन आस्क योर डाउट. Pranit, you can ask your doubt. Anjani, you can ask your doubt. If you are having any kind of doubt, you can ask me beta here only. I'm here to solve your doubts only. So let us see beta. Simple way में मैं एकदम लेके चल रहा हूँ. You know, we are going in a very simple and slow manner so that each and every student will understand. Okay. So let us see. He have given the 4 surfaces. Okay. So 1, 2, 1, 2, 3, 4. Okay. He have given the 4 surfaces. Surface 1, surface 2, surface 3, surface 4. So what will happen? What I have told you, that before we have seen one case where you will see that if any body is there, let us say if I am sitting in this particular room, then I will be exchanging radiation with all the bodies I am surrounded with. Okay. So some part of radiation maybe goes to like fan, some part of radiation maybe go to like AC, some part of radiation maybe goes to my laptop, my mobile, my chair. So something like this you can easily do this question and you can understand this question. So my dear students, यहाँ पे क्या हो रहा होगा? यहाँ पे क्या हो रहा होगा? You can see that some part of radiation, if you are talking about the radiation for the surface one, my dear students, so what will happen there? Let us see. कैसे रेडिएशन एक्सचेंज होगा? तो बेटा हो सकता है कि वन से रेडिएशन जाए और टू पे चला जाए, तो देयर विल बी रेडिएशन एक्सचेंज बिटवीन सरफेस वन एंड टू, और वी कैन से द सम, मान लीजिए यहाँ से 100 का रेडिएशन निकला। मैं आपका कंसेप्ट भी साथ के साथ क्लियर करते जा रहा हूँ ताकि नेक्स्ट क्वेश्चन में आपको दिक्कत ना हो, आपका थ्योरी भी रिवाइज हो जाए और आपका क्वेश्चन भी हो जाए बेटा, ठीक है। सो यू कैन सी दैट सम पार्ट ऑफ रेडिएशन इज कमिंग फ्रॉम दिस and going to the surface 2, very good. Some part of radiation which is leaving surface 1 and reaching surface 3, there can be some part, okay. Some part of radiation which is leaving surface 1 and reaching surface 4, that can be possible. So if you will see this, there will be 3 heat transfers, like from 1 to 2, like from 1 to 3, like from 1 to 4, my dear students. So if I want to calculate the total heat transfer, that is Q total for the surface one. So what will be this? This will be equal to nothing but Q14, or we can say the heat exchange between 1 and 2, 1 and 3, 1 and 4. Okay. So Q12 plus Q14 plus Q13. So this will be the total heat exchange between the one with the surface one. Okay, that surface one will exchange heat with all the bodies. Okay, now let us calculate the each and every heat. Okay, but how is exchanging the heat? So let us calculate the Q12 first. Q12 first. So they have given the surface shape factor F12. So let us calculate the radiation heat exchange. Radiation heat exchange. Beta, you can ask me your doubts in the comment box. Okay. So radiation heat exchange between surface one and surface two Okay, directly I'm doing the question here only, so don't worry, so that we can save the time. So radiation heat exchange between surface 1 and surface 2. So Q12, can I calculate the value of Q12 or E12, EB12? So because black bodies are given, he have already told us that all the bodies are black. Okay, all the bodies are black. So let us see. So Q12 will be given by F12 multiplied by A1 into sigma, and the temperature of T1 to the power 4 minus T to the power 4. So from this formula, you can directly have the value of Q12. So let us calculate it. So what is the fraction of radiation leaving surface 1 and reaching to F12 shape factor? So this is given to be how much? 0.26. 0.26, my dear students. Okay. Multiply by what is the area A1? This is nothing but 0.5. 0.5. Okay. Into sigma. What is the value of sigma? That is nothing but 5.67 into 10 to the power minus 8. And what temperature he have given? T1. What is the value of T1? T1, T3 is equal to how much? 1200 Kelvin. So you can directly take the value of 1200 to the power 4 minus what is the value of T2? This is 800. So you can directly take the value of 800 to the power 4. So my dear students, this will become equal to how much? Let us calculate it. The value of this will be equal to how much? Let us see. So this particular value will become equal to how much? 12,265.34 kilowatt. Okay. kilowatt. So this will be nothing but, it will be in watt, not kilowatt. So this will be nothing but 12.265 kilowatt. 265 kilowatt. Okay. This will be nothing but 12,265 kilowatt, my dear students. So you can easily take this value. So let us see. We have calculated the heat transfer between Q1 and 2. So let us see the second one, Q13. Q13. So if you will see Q13, this will be nothing but F13 multiplied by A1 into sigma into T1 to the power 4 into T1 to the power 4 minus T3 to the power 4. But this will be equal to 0. Why, my dear students? Because we know that T1 is equal to T3. As T1 is equal to T3, that's why this value will become equal to 0. So Q13, there will not be any kind of radiation exchange between the surfaces 1 and 3. Okay. So let us see for the Q4. Let us see for Q4. So if you will see the Q4, so what will be the value of Q4? That is Q1 and 4. If you will see both these surfaces. So if you will see, there is a symmetry. There is a symmetry between surface 1 and 2 and 1 and 4. So they are symmetric. They are symmetric if you will see. They are symmetric. So can you calculate the value of particular shape factor? Yes. So F12 plus F12 plus F13 plus F14 is equal to 1, my dear students. Okay. F12 plus F13 plus F14 is equal to 1. That is the net radiation heat exchange between surface 1 and all. Okay. Now, if you will see the reciprocity theorem, what will happen? Because F12 they have given, F12 they have given, F12 they have given, but F12 and F14 are symmetric. F12 and F14 are symmetric. So 3, 2, 3, 1, you do not have a 3, 1. So if they are symmetric, but F14 already given, so directly you can have. So F14 they have given to be how much? F12 they have given to be like how much? F12 is, they have given like 0.6, 0.26. Okay. And you know that particular this F14 is symmetric like F12. So this will be also equal to 0.26 because all other values are not given and you will not calculate. So by symmetry, you can have the value of F14. So these are symmetric phases. So that much of amount, the temperature of this is same because T2 and T4 are same. And also F14 and F12 are same. So you will see that Q14 will be also equal to nothing but this value, that is nothing but 12.26 kilowatt, my dear students, 12.26 kilowatt. So the net radiation heat exchange in this will be nothing but 12.26 plus 12.26, and this will become equal to nothing but 24.5 kilowatt. 20, but he is asking in the watt, so you have to write 24,24530.6 watt. 0.6 watt. So this will be your answer, my dear students. Okay. I hope this question is clear. So you can ask me any doubt. Anjani Pranit, Aritra Ghosh. Okay, tell me your doubt, beta. Tell me your doubt, please. So like these simple questions they are asking. Like these kind of simple questions they are asking.